All right, so we're going to talk about for three visible wavelengths running, let's see, 1.5 watts at 450, 1 watt at 520, and 1.5 watts at 635. These are the ODs required, and we can verify those in EasyHas. 450, we have 1 watt, so, and we'll use a small beam. And that'll give us an OD of 3. Was that correct? Yeah, 1.5. Sorry, 1.5 watts. 1.5 gives us 1385. That would be the same for the 638. Also, since the MPE is the same throughout the visible, we'll get the same OD value if we're running the same power. And of course, at 520, that is 1 watt, and that's going to be an OD of 3. Okay. And even though we have a little bit of a uptick here, this is considered just an OD of 3. All right. So what the question here is we have this eyewear filter, this 065C, and these are the ODs that the eyewear has. Are these sufficient? Okay. So we want to know how much light can we leak through this eyewear and make a case based on the standard that it's safe, because people who work with outputs that are in the visible light, they like light leaking through the eyewear so they can see the beams that they're working with and do their alignment, do the tasks that they need to perform with these lasers. So how much can we leak through this eyewear and let them see it? So we can look at each one of these and look at the filter and decide whether or not at this particular wavelength, at this power level, is this OD okay. But we need, as I said before, to back this up with the standard. So let's go look at the standard. Ask ourselves a couple of questions. We already know that what a Class 2 laser is. A Class 2 laser is a visible laser that is running a continuous wave no more than 1 milliwatt. So Class 1 is 400 microwatts, so between 400 microwatts and 1 milliwatt, that's where a Class 2 laser is. And what we say is that you can, 1 milliwatt for a quarter-second exposure, that's what your aversion response is, so it'll protect you, right here, afforded by your aversion response. Visible part of the spectrum, according to ANSI, 400 to 700 nanometers. Quarter-second exposure of 1 milliwatt, you don't need any eye protection. So let's go take a look at that with EasyHas. And we'll just, it's a visible wavelength, that's all we care about. So we have 520, let's put 1 milliwatt in there. And we'll see that, yeah, we have no OD requirement. So we're allowed 1 milliwatt for a quarter of a second. So we know that if we nail the OD value calculated for the eyewear, in other words, let's say we at 520 we had 12 milliwatts, okay, we would need an OD of 1.088. If we had this OD exactly at 1.088 in the eyewear, it would leak 1 milliwatt, okay. So how would I know that? Well, let's take this OD of 1.088, and we're going to go use the software here, and we're going to go back and use it here in a second when we look at those the real power levels and wavelengths of what we just were discussing, the 450, 520, and 638. But right now we'll just look at this. The OD, we go to the optical density transmittance box, and we're going to put in 1.088, and it tells us that we have a transmittance of 8.166 times 10 to the minus 2. All right, so we're going to take that and we'll say 8.166 e to the minus 2 times 12 milliwatts, which is 0.012. That equals, yeah, you'll see that's 9.7, that's 9.8, that's almost 1 milliwatt. It's leaking basically 1 milliwatt. So there you have it. If we take this, change it to the transmittance, multiply this times the power, it tells us how much power we have left coming through the filter. And in all cases, whatever OD requirement we have for a particular power level in the visible, it will leak 1 milliwatt. So let's say 1 milliwatt is our low limit of how much we'll leak, because we're allowed to do that, 1 milliwatt. But we don't need to leak any lower than that if we don't want to. So, and I've worked with 1 milliwatt, and you can see that really well. You might want to leak some more if the ambient light is high, but how much more can we really leak? Well, through the eyewear. Let's take a look. Our next class, and the one we're going to be considering, is a 3R. Okay, and what I want to do is come down here and look at the requirements for a 3R control measures. There's no requirement. There's no requirement for training, LSO, and LSO are engineering controls. I'm sorry, right here, not required for 3R. Same as a class 2. No requirements. Okay, so what is the maximum output of a continuous wave visible 3R laser? What is that limit? Well, we know it's 1 milliwatt for a class 2. So what I want to do here is go to page 21 and 19, 20, and 21 and look at the classes here. And really what I want to do is, we already know that a class 2 for a quarter-second exposure is 1 milliwatt. That's what we're allowed. Okay. 3R. A class 3R laser and laser systems include those that have an accessible output between 1 and 5 times the class 1 AEL for wavelengths shorter than 400, longer than 700, or less than 5 times the class 2 AEL for wavelengths between 400 and 700. So that's our answer. A 3R is 5 times the class 2 limit. So that means a 3R laser is, the maximum output is 5 milliwatts. Okay, let's just go back and see what 5 milliwatts looks like. If I put 5 milliwatts in here, okay, I have an OD value of 0.7. Now we already know that if I take that, find the transmittance, multiply the transmittance by 5 milliwatts, I'll be leaking 1 milliwatt through there. But it's about a 0.7 OD from a 1 milliwatt laser to a 5 milliwatt laser, okay, 0.7 OD, that we're going to try and make a case that 5 milliwatts is okay to leak, that it's relatively safe according to the standard. So let's move on in the standard here. And where I want to go now is page 25. Okay. And it says that a 3R is exempt from any control measures other than forms of surveillance, or other forms of surveillance, except for conditions of direct viewing of the beam or a specular reflection. And we mean by long-term viewing of that beam, or unattended operation with the beam directed into a location where it can be directly viewed either by general public or other personnel. Okay, so really what we're saying, unless there's something intentional going on here with the 3R, it appears a 3R is a fairly safe laser according to the standard. But I think we need to go in and look at eyewear specifically, that how it's called out in the standard. So we'll go down to page 38, 34, 35, 36, 37, 38. Okay, and we want to look at eye protection. Now notice they're only claiming eye protection class 3B and 4, but if we slide down just a little bit, and this is the OPE is laser eye protection. Okay, so laser eye protection. We want to go down and look at a 3R. Laser eye protection is usually not required for class 2 or 3R lasers or laser systems except in conditions where intentional long-term staring greater than a quarter of a second direct viewing is required. Okay, so what we're saying is to work with a 3R, so long as we're not going to be intentionally long-term staring into this direct viewing, so there's no direct viewing required, the standard sees that this is not a very high risk and says, yeah, we don't, the standard says you don't have an eyewear requirement for class 3R. That goes along with what we just saw, that you don't have any control measures, no control measure requirement for 3R. So that gives us a pretty good feeling based on the standard, and you can look through the standard for other references, but we're going to run with it's safe to work with up to, but not over 5 milliwatts. We would have a hard time justifying with the standard the use of anything over 5 milliwatts. Okay, so that brings us around to, let's take a look at each one of these beams, calculate the transmittance for this OD, and see how much we're leaking for this. So this is 450 at 1.5 watts. Any wavelength, visible wavelength works, but we'll go ahead and use the appropriate one, 1.5 watts. Okay, and the OD for the filter is 3.17. 3.17. So we're going to come up here and go get the OD transmittance calculator. And, ooh, what did I forget? That again? 3.17, yeah, okay. 3.17. And what's the transmittance? Oops. Didn't mean to do that. Miscellaneous OD transmittance. 3.17. Okay, so the transmittance is 6.76 e to the minus 4. So that is 6.76 e to the minus 4. Okay, times 1.5 watts. Okay, so that's leaking exactly 1 milliwatt. So we're fine with that filter at 450. Okay, so let's go take a look at the next one. The next one is 520 at 1 watt, and it's 2.33. 2.33. So let's get that. 2.33. Okay, that's 4.677 e to the minus 3. So that is 4.677 e to the minus 3 times at 520, that was 1 watt. At 520, that's 1 watt. So that's times 1 watt. Okay, that would be times 1. Let me do that again just to make sure. Yeah, 4.677 e to the minus 3 times 1 equals, shoot, okay, hold on, sorry, 1 watt times 4.677 e to the minus 3 equals, okay, so that's 4.6 milliwatts. So I had it right the first time. 4.6 milliwatts. Okay, so is 4.6 milliwatts okay? Yeah, it is. It's under our 5 watt limit. So it's like a 3R output, our 5 milliwatt limit. It's under our 5 milliwatt limit. It's like a 3R output, and we're comfortable with saying that you can work with up to 5 milliwatts, right? Based on what the standard said. So let's take a look at the next one, which is 638. 2.81, 638 at 2.81. So you got 2.81, and that is 1549, 1.549 e to the minus 3 times, and that is 638 is 1.5 watts. Okay. So that's leaking 2 milliwatts, and that's fine. So if we take a look at, and we'll just verify that was 1.5 watts. Yeah, it's 2 milliwatts that we're leaking. Okay, and so leaking 2 milliwatts is fine. You should be able to see 1 milliwatt, 2 milliwatts, and 4 milliwatts through the eyewear nicely to align those beams. Now, what if all 3 of these were running collinear simultaneously, and they were collinear? Well, then you have to look at, you've got 4, 2, and 1. That's 7 milliwatts. All right, that's over our 5 milliwatt limit. So that means that if all 3 beams were running simultaneously, they're collinear, we would have to reduce the total output to to 5 milliwatts or below. And that's what we can justify with the standard. Now, if you said these are collinear and we are only running 7 milliwatts, that's not much above the 5 milliwatts. That's where you would have to, as an LSO, make the call and go with your training, because technically you're into a 3B at that point, and the standard requires control measures unless the LSO overrides that. But as far as, I think, an eyewear manufacturer, you can recommend going up to a leakage of 5 milliwatts, but not above that. And so we've seen that it's that rule of thumb that was mentioned of a half an OD. It's really about 0.7 OD is your kind of rule of thumb of what we could really say is about 0.7. So a rule of thumb of a half an OD is, yeah, we could go along with that. But you can see how we want to look at this and how we state it from the standard, that even the standard backs us up on saying, hey, it's pretty safe to work with 5 milliwatts. What would we need to do for the customer is just make them aware that there would be a little higher risk, and make sure that the people using this eyewear, they're skilled and they're trained, and everyone is trained for understanding this little bit higher risk of working at unprotected, at no protection for 5 milliwatts. In other words, the eyewear is leaking 5 milliwatts. Okay, so if you took a hit from that, it's going to be really bright. You're not going to want to do it again, but you're certainly going to be okay. All right, I hope this makes sense, and let me know if you have any questions. I probably shouldn't do this this late as I kind of stumble through it. But anyway, I hope that you get the gist of it, and if you have any questions, let me know. All right.